Hello everyone, good morning. Today we're going to discuss about RAID levels. What is RAID? RAID means redundant array of inexpensive independent disks. That is called RAID. RAID combines multiple disks into a single logical unit to provide fault tolerance and performance. RAID provides fault tolerance by using disk mirroring and disk parity. So what is fault tolerance? Fault tolerance means less failures. Almost how we are saying 99.999% success rate. So here 99.99 99.999 failures, less failures. So that way fault tolerance is nothing but less failures, no failures at all. So that is called fault tolerance. So using RAID levels, we combined multiple disks together and configuring a RAID. Configuring RAID means there are types of RAID levels. Okay, so simple RAID, mirror volume, striped with parity. These three RAID levels we usually configure in a multiple hard disks. That is called RAID. Okay, so what is fault tolerance? The ability to survive hardware failures. Fault tolerant volume provides data redundancy. Redundancy means copying the same data in multiple disks, called redundancy. Fault tolerance volumes are not a replacement of for backup. See, fault tolerance is not a replacement of backup. Backup is different. Fault tolerant is different. See, fault tolerance means data, less failures, less data loss. So so fault tolerant volumes provides data redundancy. Data redundancy means same data we can maintain multiple disks. Same data we can maintain multiple disks. So read see this is RAID 0. RAID 0 means simple volume. In simple volume we call RAID 0. Okay, so how the RAID 0 is, see, block 1 3 4 5 7 2 4 6 8. So these are all hard disk. Block means hard disk. So we are maintaining the data in the both disks. I will show you another way so that you can easily understand. RAID, one moment. There is a simple and easy thing. Where I forgot. Okay, I will draw. No problem. So RAID, in RAID 0, how the data is storing in the multiple hard disks. Okay, later. Okay, just all shapes. Yeah, this is one. One moment. So in RAID 0, how the data is, sorry, in RAID 0, how the data is storing in the disks. Okay. So let me take 2. No, let me take this 1 disk. This is 1 disk. Okay. Disk 1. This is disk 1. Here, disk 2. Okay. And this is my computer or server, whatever. Okay. This is, let's say, server. Okay. The server storing the data okay, to these disks. Not like that. So how the data is storing? One moment. Just okay. This is disk 1, disk 2. Data is storing in both disks from here to here, from here to here. Okay. How the data is storing? Okay. Here I'm storing the data. What data I'm storing? 1, 2, 3. This is the data. Let's say example 1, 2, 3 is data. So how the 1, 2, 3 is storing in this disks? 1, 2, 3. This is how storing. Same here also. Same here also. See here data, how the data is storing in multiple disks. Here 1, 2, 3, here 1, 2, 3. This is called RAID 0. RAID 0 or simple volume. No, I'm sorry. This is different. Okay, sorry for the confusion. So this is RAID 0. Okay, RAID 0. RAID, 1 minute. RAID 0. How RAID 0 works? How RAID 0 works? RAID 0 means, what is RAID 0? RAID 0 is simple volume. Simple volume. Simple volume. We call simple volume or RAID 0. So how RAID 0 works? So this is wrong. So RAID 0 works here 4, 5, 6. This is the data. So the server is the server is storing the data into disks. How this 1, 2, 3, 4, 5, 6 data will store in the disk is 1, odd and even. 1, 1, 3, 5. So odd and even way the data will store. Here even 2, 4, 6. See, the data storing in odd and even. If you read this, minimum 2 hard disk, data is written alternatively and evenly 2 or more disks. Spanning is available, fault tolerance is not available, read write speed is fast. See here 1, 2, 3, 4, 5, 6 data stored in disk like this alternatively. If the server is write one data here, next data here, and next data here, so alternatively storing the data like this. So here no fault tolerance, and also data writing and reading speed is very fast. Here writing and reading speed is very fast, and fault tolerance is not available, means there is a chances of data failures. If the fault tolerance is available, then there is no chances of failures. So there are chances of failures here. So for example, if 1, 2, 3 data is gone, then you cannot retrieve. You cannot retrieve. This is RAID 0 called simple volume. Next is RAID 1. How RAID 1 works? RAID 1. How RAID 1 works? So here RAID 1 is little different. Okay. Here data will be stored server data 1, 2, 3, 4, 5. 1, 2, 3. Okay, just see here in RAID 1 means mirroring. RAID 1 means mirrored volume. We called mirrored volume. Either way you can call mirrored volume or a RAID 1 volume. This is called mirrored volume. See, in the name itself, it's a mirrored. So the data will be stored like this. Data will be stored like this. See, the same data will write in the both disks. If one disk is fail, we can retrieve the data from another disk. We can retrieve the, if this disk is fail, still the data will be available. So fault tolerance. We have a fault tolerance. See, minimum 2 hard disks is required to configure mirrored volume, RAID 1. Simultaneously, data will be written in 2 volumes on 2 different disks. Any volume can be mirrored, including the system and boot volumes. Fault tolerance is available. So here fault tolerance available means we have a less failures. We have a less failures. Read is read speed is fast, write speed is slow. Why write speed is slow? Because the same data will be write in 2 disks. So that is the reason write speed is slow. But reading speed is fast. When you read the data fast, but when you write the data into the disk is slow, because the same data will be written in both disks. That is the reason writing speed is slow. Okay, 50% overhead. So here we have a 50% uh, uh, less 50% we can retrieve the, I mean, failures. Next, we will get less failures. Okay, here in uh, RAID 1 mirrored volume, and coming to striped with parity, RAID 5. RAID 5. RAID 5. How RAID 5 works. So RAID 5, let me copy this. So RAID is, 1 second, let me delete. RAID is striped with parity. RAID is striped with parity. How this will work? See, minimum 3 hard disks are required to configure RAID 5. Data is written alternatively and evenly to 2 or more disks, and parity is written on the in one disk. Fault tolerance is available. Read and writing speed is fast. So this is read and writing speed is fast there. So when compared to RAID 0, 1, RAID 5 is powerful. RAID 5 is powerful. Here fault tolerance is there. Read writing speed is more compared to them. And data is written alternatively, evenly, 2 or more disks. Here only 2 disks. If one disk fail here, if one disk fail, what will happen? Data will be lost because we cannot retrieve. But here data will be written in 2 or more. 2 or more. So this is disk 3. Disk 3. This is disk 3 and data writing is like here 1 3. See 1 3 and parity. So parity means 5 and 6. Okay, and here in disk 2, in disk 2, 2 plus parity, P is equal to 3 and 4. Next here 5. Let me down this so that, oh, sorry. And let me down this. And here, how the data is storing, P is equal to here 1 and 2, okay, 4 and 6. See, this is how data will store. Here data is 4, 5, 6. See, our data is 1, 2, 3, 4, 5, 6. So how the data is storing? 1, 3, okay, 1, 3, and parity. Here parity is 5, 6. So here 2, 5, parity 3, 4. Here 6 is missing. Here 4 is missing. And here parity 1, 2, 4, 6. So if any one of the disk is failure, let's say this disk is failure. Okay, anyone. Let's see, are we have are we having a full data or not? Here 1, 2. Here 1 is missing, the data is here. Okay. 3, here data is 3 is there, so you're not there, but still we can retrieve the data from here, both disks. So from the both disks we can retrieve 1, 2, 3, 4, 5, 6. We can retrieve 1, 2, 3, 4, 5, 6. See, 1, 2. Here there is no 1, but still we can retrieve the 1 from here. 2, in both places 2 data is there, still we can retrieve. And 3, 4, here 3 is not there, but we can retrieve from 3 from this disk. 4, both places, no problem, we can retrieve. 5 here, there is no 5 here, we can retrieve from here. 6, there is no 6 here, so we can retrieve. So finally, we will have a full backup of our data. 1, 2, 3, 4, 5, 6. This is RAID 5 works striped with parity. Here, if one disk is failure, 50% of data will be gone. Here, if one disk is fail, still we have a 50% of data with us. Both fails, then, but both disks will not fail. Okay, that are very less chances. But so in the organizations, RAID 5, they configure RAID 5 disks. RAID 5 disks because here sustainability and fault tolerance is more. See, speed is more, reading speed is more, fault tolerance is available, means less failures, very less failures. Okay, so data is written alternatively and evenly, 2 or more disks, and parity is written on one disk. Parity is written on one disk. So this is RAID levels. Okay, so yesterday we configured like target server initiator. So using target server, we create a virtual partitions. So similarly, let's configure RAID levels using this. Let's create a RAID volumes like this. Simple, mirrored, striped. We'll create 3 volumes. Okay, using this. So any questions?
No, sir.
So did you understand this? This is very important. You will get questions in the interview. What is RAID 0? What is RAID 1? What is RAID 5? Differences. So 1, 2, 3, 4, 5 is the sample data. So how the data is storing in RAID 0? How the data storing in RAID 1? How the data storing in RAID 5? So, um, so you can suggest your organization to configure RAID 5 because our data losses is less here. Because see, data is writing in more than 2 disks. So still, if one disk down, if one disk failure, so still we can retrieve the data from other 2 disks. This is very important thing. Okay. If you don't understand, let me know. I will explain. If you don't understand anywhere, let me know. Refresh. So mount points. A mount point is a reference to a location on disk that enables Windows operating system access to the disk resources. So use mount points. Mount points is nothing but, for example, you have a data in a different place. So every time you are accessing the data through network path. So you want to make it a drive. Then you can create a mount point. So for suppose, see, this is home. There is a home directory which we shared in the network, right? Home. What are the okay? And one second, softwares. Okay, so let's take this. This is a software folder. I'm just sharing the software folder. It is already shared. Win hyphen ad software. So this is the network path. So usually I'm accessing this path every time, every day, every time. I mean, so oftenly I'm accessing this. So we can make that, we can make that, we can mount that path in our computer. So how? Right click on it, map network drive, and give folder. Okay, and give drive name like H, finish. Okay, just close it. See, this is like a drive. This is shows like a local drive, but accessible. This is accessing. This is from other server, but we feel it is locally mounted. So this is how we mount uh, paths in computers. Okay, leave it. So coming to file storage and services, and go to iSCSI. Here create a new iSCSI virtual disk. Create. So last time we took from D drive. Okay, now I will take space from C drive. Okay, so v disk 1, v disk, sorry, 2, v disk 2. Click next. So here I'm just giving 8 GB. Okay, 8 GB. Click next. Click next. See, create. So 8 GB disk we created. Okay, so under the same target, coming to here, go to files and this server, other server, just refresh. iSCSI. Here, see, there is a 50 GB, and here, 1 second, refresh here. So I created a disk here, coming to here. One second. Yeah, 8 GB. Here it is not showing 8 GB. Volumes. Okay, I will do one thing. I will create one more target. I will create one more target. Yep, one more target. Disks. No, iSCSI, got iSCSI here, right? Target 1. It is connected target 1. 8 GB. Okay, good. Now, it is already under target. Let's go to here, iSCSI. iSCSI initiator. Just refresh. Disconnect. Just yeah, still connected. Okay. Now go to disks here. 1 GB, 50 GB, not showing here. Server. Why it is showing 1 GB? storage pools. Let's go to storage pools. Refresh here. No, it's different. It's not coming to disks. Why it is not showing? One moment. I will disconnect and reconnect. iSCSI. Disconnect. Yes. It is not showing up here. D drive. Extend. No. Assign. Yeah. Let's assign. Assign this disk to. Let's existing disk. Assign. Click next. Assign. Yeah. Close. Now refresh. So after assigning this disk, you can see here. See, now you can see here. So we didn't forgot to assign. So we assign after creating, we need to assign this disk. Now it is showing here. See, now it is showing. Okay. See, now we need to bring this disk to online. Now we need to bring this to online. Right click on it, bring online. Yes. Refresh. Okay. Now go to storage pools. So in storage pools, see, you can see 8 GB here. See, now you can see the 8 GB. So after that, you can create a partitions. Now you can create a partitions. So let's create a multiple partitions from the storage pool. Okay. So right click on it, new storage pool. Click next. Pool name. You can give pool name here. Pool 2. Pool 2. Okay. Click next. So this is 8 GB disk. Select it. Click next. And create. Now we are creating pool. See, close. Just refresh it. Now select pool 2 and here right click on it. Sorry. Here you can create a partitions. Click here. Click next. Select pool 2 and here just give simple volume, simple disk. Simple disk. I'm just giving simple disk. Click next. Select simple. See, simple. Data is striped across the physical disks, maximize capacity and increasing throughput. So, but decreasing reliability, storing the storage layout requires at least one disk and does not uh, protect you from a disk failure. So if any failures, you cannot protect by the simple. Okay. So here you need to give thin or fixed. I'm giving thin because the storage space automatically increased by the data. If the data is increasing, automatically storage space will be increased. So I'm giving 2 GB. Click next. Create. Close. Click next. Click next. So in 2 GB, you will get 1.97. So you can give PQRS. Okay, P. I'll give you P. So simple disk. Give simple disk. Click next. Create. Close. Okay. So likewise, you can create. For example, if you create new disk, click next. Select pool 2. So pool 2 is a storage pool. From the storage pool, we can create multiple partitions. So here now I'm just giving mirrored disk. Click next. Mirror. Click next. Enough space. Okay. This pool does not contain enough space. Okay. So mirrored needs uh, more space. So 3 okay. I think I supposed to give less space, but I gave more space. Okay, I'll do one thing. Let me create from pool 1. Mirrored disk. Mirrored. Click next. So mirrored needs, see, the storage pool does not contain enough physical disks to support select a storage layout. Okay. So parity also need 3. Yeah. These also, again, we need to create storages here. Again, we need to create a, I think I supposed to give, 1 second. Properties, can we, no, only 2 GB, 2 GB. So that we need to create a disks like in mirror 2 disks and striped 3 disks. So simple 2 disks, mirror 2 disks, and RAID in RAID 5 we have to create 3. So we don't have a space actually here. So similarly, you need to create disks here and add to pool. From pool, you create a disks. Okay. We don't have a space here to create. See, the error is, if I create what the error is saying. Mirrored. Click next. The storage pool does not contain enough physical disk to support. Select a storage layout. Select a different layout. So we need to add a more space here. More space. Then only we can create. Then only we can create 2 disks here and 3 disks here. Okay. You practice it and let me know if you are okay. You need to see it totally how many disks you need to add here. Total for simple volume 2, for mirrored volume 2, For striped volume 3, 3 to 5, 5 plus 7 disks we need to create here. So, but when you practice it, don't give 4 GB, 2 GB, just give 2 GB, 2 GB, 2 GB. Okay, so that you can create 7 disks. So using 7 disks, you can configure RAID 0, RAID 1, RAID 5. So that's all for today. Any questions?
No, sir.
Okay. Did you understand the concept, the RAID levels?
Yes, sir.
Yeah, how the data is storing in the RAIDs. In RAID 0, see the data is storing 135, here 246. So if one is fail, you will get 50% data only. You cannot get retrieve 100% data. In RAID 1, if one disk is failed, still you will get the data. Because the same data will be written in both places, 1, 2, 3, 1, 2, 3. But here, if here both disks down, you cannot retrieve the data. But the situation never down, never corrupt both disks at a time in real time. So in striped, if one volume is fail, if one disk is fail, you can retrieve from other disks. So this is what RAID levels. This is important. You must get questions on this in the interview. So thank you all. Thanks for joining. Have a great day. See you tomorrow. Tomorrow will be the last class. Okay. Thank you.